Champaign, Urbana, in case you've never been there before. It's a 24-hour trip from here up to Saskatoon. Here it's 68 degrees. Like Auden said, we came into a nuclear winter snowstorm to get here. I have long johns on. So it is quite distance away, but you're welcome to come down anytime, the university. We'd love to have you down. It was built in 1867, it's the founding year of the University of Illinois. I'd like to tell you a little bit about it, just basic knowledge. We have 17 colleges, instructional units, 44,000 students. There's 316 main buildings, and then there's about 800 more that aren't considered main. And so about 1,000, 1,100 buildings on campus. And we spend about $563 million on research and development. Quite a bit of money is flowing through the university. And when we think of research and development, we have the scientists, right, in the laboratory trying to figure out new ways to do things. But what do you think of in terms of energy? R&D does equal energy. To perform research and design, you need to have the power, you need to have constant source of power, and the heating and cooling perhaps in certain laboratories. So what our job then in retrocommissioning at Illinois is to try to balance those two items. How can we go and meet with them? And it can be a very capricious place, right? Where you're trying to balance the research, which they have perhaps flies that they're researching for the past 30 years of these generation, and they can't lose them. Otherwise 30 years of research is down the tube. And so how do you protect that, but at the same time reduce the energy expenditure in the building? Well, let's talk about energy on campus. We produce our own chilled water, and we circulate it around the entire campus. This is one of the buildings, the chilled water plants. There's 3 of them, and then some auxiliary units, and they pump around, the capacity is about 40,000 tons of cooling. And we have a connected load of 34,000, so we have 11,000 houses that are connected onto this. We generate our own steam as well. About 10 turbines or boilers. 3 of them are natural gas. 3 of them are coal-fired. We also have a way of generating steam by using what they call HRSGs, or heat recovery, and the steam generation off the engine. And then we use that to create more steam. And so the total capacity of this is about 900 million BTUs per hour at peak load. Think about the size. And from there we also generate our own electricity. 54 megawatts at peak capacity. In 2007, the Utilities Division started to notice that we're getting ourselves into a hole at the university. We had a deferred maintenance backlog. We hired a third-party audit to come in and look over all of campus and see how many buildings were behind in their maintenance. And they ended up revealing that there's millions of dollars of deferred maintenance. There's also a steep rise in the utility rates. In our area. It went up, the utility budget went into the whole $90 million, and so now we had to start figuring out ways then to reduce our energy. We're a state funded, and as well then we had to, or provincial funded as you might perhaps say, and then we had to look for ways to save energy. We also had institutional commitments. IC Canada has something very similar to this, College and University's President's Climate Commitment, trying to make us energy independent as quickly as possible. We also have our own internal university climate action plan. I have a copy of that right here that I brought with me. A policy written by the provost and the chancellors and the board of trustees about how to go about achieving our climate independence. One of the things, a couple of things they mention in here are mentioned interesting in Auden's book. It talks about by 2015 a greenhouse gas fee will be imposed on all automobiles on campus. So you drive to campus, you will be charged for bringing your automobile to campus. Better ride your bike or take the bus, or you're going to have to start paying. Another thing, building standards, everything will be LEED Gold. By 2015, every new building will be LEED Platinum. If you do any major renovations, they're going to have to go Platinum. But there's an interesting dilemma that we're starting to face there. Even though you have the green LEED building, is it LEED a year from now? Or is it LEED 2 years from now? And that's the real question as time goes on. So our path to energy reduction, we've discovered 7 different ways that we're going to approach this. First, we need to meter every single building. Meter their chilled water, meter their steam by means of condensate, and meter the electricity. Monitor that every month. We also decide, like I mentioned, we have a different group doing lighting retrofits, specifically in lighting. That's their job. Replace every light on campus with higher efficiency lighting. They're dedicated to that. Retrocommissioning. We have thermal storage now on campus, a 6 million gallon tank that houses 5,000 tons of chilled water, and they're trying to get it up to 8,000 in a couple of years. So that's on campus, and we're using the ESCO. And we noticed that even though we can come up with this list, we needed to involve everybody on campus. We needed the board of trustees involved. We wanted the students to be part of this. We wanted to go out and get university administration. We applied for grants. These are granting agencies, Department of Commerce in the state of Illinois, Energy, or the Clean Energy Act as well for Illinois. Went out and found money to start to provide these systems. So we're going to focus on retrocommissioning. And retrocommissioning in Illinois may be different than retrocommissioning in other parts of the world. And when I say that, because we have a specified group already taking care of the lighting. So if we add up what are the other three bigger chunks that we could put together, well, I'm an HVAC engineer, so I look at heating, and then I look at ventilation, and then I look at cooling. And if I add those up, I get 51% of the building's energy is going to HVAC, and 21% to lighting. So I'm going to dedicate then a team to only review HVAC systems. So we found the optimal solution is to have people who know something about HVAC and controls. So this gentleman is the ultimate manager of the whole program, Carl Helmick, and myself and my friend David Harden are managers of 2 teams. That's why we crossed out one building at a time, because that was when it was just us, and then we brought on this guy, so we made 2 buildings at a time. We got 2 teams now going out there and attacking buildings. He's a nice guy if you ever get to meet him. We also thought we need experienced control programmers. These guys just sit in there and know code. And so they're just good. But what's also helpful is they know HVAC systems. So they understand how the whole system should work, and then they understand the detail of what to program to make it work. We also have a unionized workforce in the state of Illinois. So we have composite crews. We send all the crews together into the building. So we send a sheet metal balancer, we send a DDC electrician, knows DDC systems, and we send a pipe fitter that knows temperature control systems, pneumatic type of system, air systems. We send those 3 into each building, and they accompany us on everything. And then we also have students. We have an internship program where we hire 3 or 4 students every semester and through the summer to help us do work. They create color-coded floor plans to know what air handling unit serves what rooms. They're out verifying where's the thermostat on the wall, taking pictures of the equipment so we can create a master list for the building facility manager. We have them do just about everything we can encourage them to do to gain experience in this. So I'm going to talk to you in case studies about 3 different buildings. The Zasis Library, Animal Sciences Laboratory, and also the Siebel Center for Computer Science. So if we start at ACES, this is an agricultural, consumer economic sciences in campus. Here's a section through the building, just to give you an idea. This basement here has an auditorium, then has some computer labs and conference rooms. This first floor is conference, and then the rest of the 3 floors are library inside the facility. Here's the control system that's there. 1990 vintage. They're called LCMs. It's Barbara Coleman's system, if you know what that may be. Just a picture of it so you can see what we play with every day. It's not very sexy, I know, but that's where we're at. We found an exhaust fan that was running 14,000 CFM constantly, 24/7. Well, how much does this building cost to operate? Well, we found it was $475 grand a year to run that small building. It's not very big at all. So as we went through it, we thought, well, we're going to try to develop occupancy schedules. Ask the people, and we meet weekly with the facility manager to discuss these ideas and bring them to the table. So we had them go, we need 3 different calendar periods, they told us. We need a spring-fall semester when the students are around. So I need you to run or have the air handling unit on for this quantity of time, which is from 8 a.m. to 11 p.m. But in the summer, we could do something different.